Let's start and do learning objectives A and B. So we're going to identify domain and range of a function and identify if a relation is a function. So the first 4 vocab words here we do want to define first. The first is a relation, and all that is a set of ordered pairs. So for example, maybe I have this set of 3 ordered pairs, 1, 2, 3, 4, and then 5, 6. Okay, let's talk domain. Domain is going to be a list of the x values related to that relation, and the range is the y values. The way that I remember domain goes with x and range goes with y is it's alphabetical. Domain comes before range alphabetically as x comes before y. And then a function says for every x, value, there is exactly and I underline that, 1 y value. So this says basically every time I choose a particular x value, if I choose 1, 2, or 3 for x, that there is exactly only 1 y value that it'll be paired up with. So for example, on this relation, if we look at this ordered pair, they're saying every time I choose an x of the number 5, there'll always only be 1 answer or 1 y value, which would be number 6. If it was the case where I chose 5 again and got a different answer, that would be a second y value, so that would not be considered a function. So let's do these 2 examples and define the domain and range, and then say if it's a function or not. Now this is just kind of a mapping of the various ordered pairs. So if you want to look at it as ordered pairs, by the way, the input is the x, the output's the y. So it's the ordered pair -2, -1, -1, 0, a 3, 0, and a 6, 4 is how you would read those ordered pairs. So for letter A, the domain consists of all of the x values. So domain is just all the x's, and all you need to do is list them in increasing order from smallest to largest, and you don't show any repeats. So the domain would be -2, -1, 3, and 6. The range consists of all of the y values, so these guys right here, again in increasing order, and you don't list the repeats. So -1, a 0, and a 4. In this case, we want to determine if the relation is a function. So think about it this way. It says for every x value, we get the same y. So every time I put in -2, I get -1. When I put in -1, I got 0. When I put in 3, I got 0. When I put in 6, I got 4. Every time I chose a unique x value, I got its own y value. Don't be thrown off that this particular one right here that you see for -1 and -3 both go to the 0 value. -1 and -3 can both go to 0 because every time I put in 3, I get 0. Every time I put in -1, I get 0. That's okay. So here we're going to say the relation is a function because each input, or x value that is mapped onto 1 y value, or the output. The second problem here, I'm going to write these as ordered pairs. Again, it's mapped, so it means -2, -2 is 1, 1, 0, 2, 2, and then 2, 3. Now the domain in this case, again, is going to be all of the x values. So -2, -1, and 2, only list at one time. The range is all the y values. So -2, 0, 2, and 3. Now for, again, is it a function? It says every time I put in an x value, I get the same answer. So notice here, they put in the x value of 2 separate times. Do they get the same answer? Well, the first time they put in the 2, they get a 2 as an answer. The second time they put in a 2, they got a 3 of an answer. They got 2 different answers, not exactly the same one. So it breaks right there, and you would say the relation is not a function because the input of the number 2 is mapped to both the numbers. I'm going to get rid of 0. It's mapped to both the number 2 and the number 3. I want you to look at these 3 and just look and see if you think they're a function. So take a moment and define if it's a function or not. Again, every time I put in an x value, it goes to the same y value. Be careful. Every time I put in a 2, it goes to 1. Every time I put in a 4, it goes to 1. That's okay. They can all go to the same answer. The problem is if you put an answer in more than once, so here they put the number 2 in twice. The first time I got 2, the next time I got 1. This one right here is no, it's not a function, and that's where it breaks. This actually breaks right here also. When they put in 0, they got 3 or 2. That's not going to work. Back to the first problem. Is it a problem that when I put in -1 or 3, I get the answer -2? They each go to their own unique answer, even though it's the same number. That's fine, so this is a function. The last one here for number 3, what you're really looking for is if there's any numbers repeated here. -2, 0, 2, and 4 are the first times you see all of those, and they all go to the same answer, which is fine. If I saw that I put 4 in again and maybe it went to the number 5, that would be an issue. But as it stands right now, this one is considered a function. Let me just list the domain and range for number 3. The domain would be -2, 0, 2, and 4. The range is just the number 4. There is another way you can tell if an equation or a graph is a function. It's called the vertical line test. And it says a relation is a function if and only if no vertical line intersects the graph at more than one point. So here we have 2 different graphs. We have this shape and we have this shape. You're going to notice I've drawn a vertical line. This vertical line crosses in one point. Now you have to imagine you've drawn all vertical lines. What if you do this one, or this one? They will not cross in more than just one point. So based on this graph is considered a function. This one here, if I draw this vertical line, it crosses in 2 points and that fails, which means it's not a function. Let me show you by the ordered pairs. This is the ordered pair 2, 2. This is the ordered pair 2, -2. So if you look at the ordered pairs of it, you can still see that it fails. Remember, for every x value, you can only have one y value. This one has 2 different y values for the same x. That's why it fails. So if I was giving this mapping, the first thing I would probably do is write the ordered pairs. I would plot the ordered pairs and see if it passes the vertical line test. So they've already started. We have -2 and 1. The next one is -1, 0, 3, 0, and then 6, 4. If you plot those points, remember this is an x and that's a y. This is the x-axis. It goes left and right. The y goes up and down. So to graph the ordered pairs, don't forget, start at the origin. From the origin to graph the first ordered pair of -2, -1. The first number is x, the second's y. To move x, you go -2, so that's to the left 2. And then you go y, which is up or down. It's negative, so down 1. That's the point. The ordered pair at -1, 0, from the origin, you're going to go on the x-axis, so it's left or right. If it's negative, you go left 1. There is no y, so plot a point. To plot 3, 0, the x movement's first, and it's positive, so this time it's right, 3. There is no y, so plot a point. The last one is 6, 4. So the x movement is left and right. It's positive, so I move right 6. And the y is positive, so I go up 4. If I draw a vertical line, any vertical line will only cross in one point. So this does pass the vertical line test, and the relation is a function. Now letter B, if we change this mapping into ordered pairs, we have negative 2, 2, 1, 0, which they've listed. We have 2, 2, and we have 2, 3. If I plot these ordered pairs, negative 2, 2, negative 2 would be on the x-axis, which is left and right. Negative is left 2, up 2. 1, 0 would be right 1 and don't move up or down. 2, 2 would be right 2 and up 2. 2, 3 would be right 2 and up 3. This one right here fails the vertical line test because it contains 2 points, so this is not a function.